Claisen condensation is a very important reaction for aldehyde and ketone, and it is similar to aldol condensation, which we have read so far. So in this reaction, ethyl acetate is treated with sodium ethoxide and the resulting mixture is acidified. Then beta ketobutyrylate, generally known as ethyl acetate or acetoacetate, is obtained. So this is ethyl acetate. In terms of base, we have taken C2H5O minus, because if you see the structure of ethyl acetate, it will give you CH3 C double bond O C2H5, and the base which we have taken is CH3 C2H5O. Now, if this base act as nucleophile attack to this carbon, it is an ineffective reaction because the leaving group and the base are identical. So there is no need, or this molecule never act as nucleophile. So this will remove hydrogen from the alpha carbon. So this is the reason we have taken the same leaving group as a base in presence of ethanolic medium. The final product consists of one ketonic group and ethyl acetoacetic, which is identical with respect to aldol condensation. Now let's see what is the mechanism of Claisen condensation. Step 1, just like aldol condensation, the C2H5O minus act as base, eliminate one hydrogen from the alpha carbon of C double bond O, generating carboanion, which is a very good nucleophile. And in the second step, this carboanion attack to another molecule of ester. Both the electron are taken by this oxygen, convert this oxygen as a negative charge. The plus R effect of this negative charge remove the molecule which is a good leaving group, that means ethylic group. So you will get acetoacetic ester. So in the final step, this is a strong acid, and when you take C2H5O minus, again it will eliminate this hydrogen which is acidic. So this will be the negative charge which is resonance stabilized. Now let us take some mixed Claisen condensation. Claisen condensation are of basically three types. One, simple Claisen condensation, which we have read so far, where both the ester group are identical. Mixed Claisen condensation, when two different Claisen or two different esters are reacted with ethoxide ion, just like this. This is a phenyl benzoate, this is ethyl propanoate treated with the base, and there is no alpha hydrogen to this molecule. So this alpha hydrogen will be replaced and this act as a nucleophile at this carbon. You will get this molecule. Similarly, another example, ethyl benzoate and ethyl acetate. It consists of no alpha hydrogen. I have taken all these molecules having no alpha hydrogen. Why? Because in mixed Claisen condensation, if you take two molecules which are reacting with the Claisen condensation, both having alpha hydrogen, will give you different type of byproduct. But in this case, the byproduct are restricted because this molecule is converted to nucleophile and it will attack to this molecule. There is one possibility that this molecule convert to nucleophile, attack to the same molecule, but if this molecule also consists of alpha hydrogen, then the byproduct number of byproduct must be 4. But if there is alpha hydrogen is absent in this molecule, the number of byproduct is 2, but the major product will be like this. The third type of Claisen condensation is intramolecular Claisen condensation, in which generally we prefer 4 and 5 member ring, just like in aldol condensation. This is one example. I have taken C2O5 minus, it eliminate hydrogen from this carbon, attack to this carbon. Same mechanism, ethoxide ion will be replaced and converted to this molecule, which is a 5 member ring. So I hope Claisen condensation all of you have understood. Do solve questions based on Claisen condensation, and remember that Claisen condensation are of three types. One is simple Claisen, second is cross Claisen, third is intramolecular Claisen. Sometime intramolecular Claisen is also known as Deichmann reaction, and generally intramolecular Claisen condensation we form 4 and 5 member ring. Do solve question.